talking.
All right, so we're going to do this question, and we want to balance it using the redox method. So what we're going to do is we're going to write Leo, and we're going to write Ger. We're going to assign our oxidation numbers, +3, -2, 0, and 0. What's being oxidized? It's got to be the one that's increasing in value. So that one is oxygen. Oxygen with a -2 charge is becoming oxygen with a 0 charge. So that's my Leo. We are losing electrons. But you have to look here first, and you have to see that this is a 3 and this is a 2, so it's not balanced for mass. We have to balance it for mass first. So let's go ahead and do that. We're going to put a 2 in front of this. We're going to put a 3 in front of that. Now we can put our electrons in. Difference between my electrons is -2 to 0. That's 2 electrons being lost, but there are 6 oxygens doing the losing. So I'm going to put 12 electrons being lost total, because again, you're going from a 2 to a 0, but there are 6 oxygens doing it. So 6 times that difference is 2. 6 times 2 is 12. That gives me this. All right, let's do the Ger. The Ger is the aluminum with a +3 charge becoming aluminum with a 0 charge. Balance it for mass. Okay, that's 2 aluminums there, only 1 there, so we have to put a 2 in front of it. And then we're going to put the electrons in. When we put the electrons in, we have a difference of 3 times the 2 aluminums, so that's going to be 6 electrons being gained. Now, this is not balanced yet because we have 6 electrons being gained and 12 electrons being lost. They're not equal to each other. So the way we fix that is we're going to multiply this equation by 2. And that 2 distributes to everything that's in that equation. Okay, 2 aluminum 2 plus 3s plus 12, that's 12 electrons, yields 4 aluminum 0s. Okay, now I'm going to highlight, if I can find the highlighter, I'm going to highlight the coefficients. I got a 2 in front of that aluminum. Wow, that's not aluminum, that's oxygen. 2 in front of that oxygen, 3 in front of this oxygen, 2 in front of this aluminum, and a 4 in front of this aluminum. So we're going to go ahead and we're going to find them up here in our main equation. We have to put these numbers in. The 2, that's right here. I don't like this color. The 2 that's right here is in front of that oxygen with a -2 charge. That's right here. So I'm going to put a 2 here. Let's go ahead and do that. This one is a 3 in front of the oxygen with a 0 charge. So this is going to be a 3. This has a 2 in front of the aluminum with a +3 charge. Now, here's the aluminum with the +3. It already has a 2 in front of it, so I don't have to put it again. It's already there. And then this 4 in front of this aluminum with the 0 charge, I'm going to go ahead and put the 4 in there. So now up here I have a balanced equation using the half reaction method, not inspection. Okay, inspection is what we did before. This is using half reactions. And what that ensures is that the number of electrons lost and the number of electrons gained, down here, okay, are equal to each other. These two are equal.